All right, so today we're going to actually do just a little couple short vignettes of C++ knowledge. We are going to go over three um, lesser known C++ things. These things are called any, they're called variant, and they're called optional. And this is all basically like C++ 17 and above options. Okay. So any and variant are I like to joke that any is a type made by Python programmers. So if we say any Raymond equals 5, that's valid C++. And then we could also say Raymond equals hello world, and that works. It's like there's no type anymore. So it is literally, there's a type, the type is any, but it can basically accept any type. And if you want to do something with this, got a little demo code up here for you, and you can have a function return an any, and you can have it return an integer sometimes and a const char star sometimes, and then Alice can receive either of those. We don't know which. We can grab what type it has by calling this, and then you can have an if statement on it saying if it contains a string, then do something. If it contains an integer, do something else. In order to get it actually into the type that it holds, you have to use anycast, and that will throw an exception if you do it wrong. So if I say G++, I compile that, I run it, you'll see that you get a bad cast. So if you do it backwards, yeah. So if it's odd, it returns an integer. Right? So if we do even, then it throws a bad cast. Okay. And so you can see the type is not what you'd expect. It's not a const char star. It's not int. It's just some string. But basically, this allows you to find out what type is in the any, and then you have to use anycast to cast it to that type. And typically, you just copy it out, right? So if Alice dot type dot name equals, it was like I or something like that, then you'd copy it into like an integer or something like that. So any is a type that can take any type. And crazy zoomed in. Interesting. I don't know. I can change the resolution maybe. I'll drop it to 1080p. Hope that doesn't break the visibility of the text for you. So that is any. Okay. And so any allows you to be a Python programmer in C++, essentially. It can dynamically on the fly change its type, which is not the same thing as like auto. If you do auto, then Raymond, this is as if we had typed int Raymond equals 5, not the same thing, right? Because you can't assign a string or a const char star to Raymond, right? But with an any, it'll take any type, and you can live out your Python fantasies as a result of it. It can be retyped. Yeah, it's essentially dynamic typing, C++ style. It's not exactly like you can't, like if you have any Raymond equals 3.4, it's a double, right? You can't just like see out the value, right? You can't do that. So you still have to, like C++ still needs to know kind of at the end of the day what type it is. And so you have to use anycast to cast it to a double, and then it will see out the value properly. It's not quite Python. And there you go. Okay. So variant is very similar to any. And is any space inefficient? It's a good question. I actually don't know how any is implemented. It's beyond my level. Like I would not be able to code it. with the knowledge that I have. So I assume they're doing some sort of type erasure on it, but I actually don't know how the underlying implementation of it works. So variant is like any, but it can only take 2 values in this case. You can have it take more. You can have it take int or string or char, something like that. Double. And so those are the only types that are allowed for it. So if you tried making it, that might actually cast. Yeah, probably cast an integer. But if you try giving it a type that's not allowed, it'll give you a compiler error. So with variant, you could do that, and then you could say Raymond equals hello world, and that'll cast from a const char starting to a string, or you can just keep it a string like that. The s suffix on double quotes makes it a C++ string. By default, if you have double quotes, that is a C-style string, not a C++ style string, and that is a rough edge that gets a lot of students, especially when they use auto. See, they think it's a string and it's not. It's a C++ array of characters, a null terminated array of characters, pointer, const char. Like, it is not what you think. It is not a string. Okay, so so with this, you can see we're having the same behavior as we did for any, right? Except if we try setting it to, I don't know, let's make a new struct submarine, or something like that. If you tried making submarine s and set Raymond equal to s, then it won't work, because that is not a type that is allowed, right? Variant allows, in this case, 3 different types. Okay. So if we want to see out Raymond, we have the same problem, which is that C++ doesn't know which of the 3 variants it's supposed to be. And so there is a standard library function called get, and you pass in the type that it is, or you can pass in a number. 0 in this case means we're going to try printing it out as if it was an integer. And if we do that, it's not an integer right now. You get a exception thrown, right? This is a string, not an integer. So we'd have to do 1 here. And we get hello world. The more normal way that I would do it is I just cast it to a string. I would say get angle bracket string, and do that. But if you wanted to, you can use the numbers as well. Whatever makes you happy. Okay. So if Raymond was an integer, we could do this. Right? So you either write angle bracket 0 there, or you write int, and that'll give you the thing. Okay. Would you get an error if you did get float? Sure. Yeah, that is just not allowed. In fact, it's not even going to compile. See, the other ones would compile and give you a runtime error, right? If we put in double here, you get a runtime error. It compiles, but it throws an exception. But if you tried doing something that wasn't on the list, like float, that's a compilation error, because the compiler knows that there's only 3 options for your variant, and that's not one of them. So if you try compiling that, you'll get a horrible error message because it's C++, right? Error static assertion failed. T must occur exactly once in alternatives. Not an especially helpful error message, but there you go. You get a compiler error. Okay. Is that sarcasm, Raymond, when you say how much you love C++ error messages? Is that sarcasm? I can't tell. Not at all. Okay. So yeah. And so you can either use 0 there. And so a variant is basically any is like a Python variable dynamic type. Kinda. It's not exactly, but it's kind of the same. Variant is like the C thing called a union. And so a union in C is, and it's also in C++, technically. I know a lot of people hate C/C++, but it's in both. So, you know, whatever. A union is, looks a lot like a struct, but it ain't. And that's in caps. Okay. So, union Eggert here has a semicolon. It looks like a struct. We have an integer x, and we have a float y. So this is very similar to a variant. Okay, so you can only have the int set or the float set at the same time, but not really, because let me show you what's so horrible about it. Horrible is maybe an exaggeration. So let's make a new Eggert called e. Let's say e.x equal to 42 and see out e.x. Notice that I don't have to do any of this fancy schmancy get stuff. It'll just work, whether or not it should or not. So, Bruce, what value is this going to print to the screen? We got into C++, the error messages were so confusing. Yes, correct. This will print 42. So, it just works. It just works, or does it? Or does it? There we go, 42. All right. So, what if we set y to be 42? Okay. What's this going to print, Megan? What do you think? It'll print 42-ish. And it's a float. There you go. Got 42. Cool. So what if you set e.x equal to 200, e.y equals 42, and we see out e.x and e.y. So, Megan, what do you think it's going to print for x and y here? $242 would be exactly correct if what we had here was a struct, but it ain't. This is not a struct. This is a union. We instead get what? The reason for this, I might be able to explain to you if I see out size of e. How many bytes is e taking up? Now, do you guys remember how many bytes a integer is on our server? It's not a part of the standard, but on our server, they're 4 bytes. Yeah, they're 4 bytes. You should know this, Bruce. It's 4 bytes, 32-bit integers on our server. That's why it goes from negative 2.1 billion and change to positive 2.1 billion and change. That's a 32-bit number. If we had 16-bit integers, which have happened before in the past, you could have a 16-bit integer under the C++ standard. Your numbers would not go up to 2.1 billion. So these are 4 bytes. What about floats? How many bytes is a float? McKinney's here. Interesting. He's on the chat. Floats are 4 bytes as well. They're 32 bits. If you want an 8-byte float, that's called a double. It's double precision. But if we print out how many bytes Eggert is, we should, like, if this was a struct, the answer would be 8, right? Because you have 4 bytes for the int, 4 bytes for the float. Let me show you why this is weird. If you run it, the whole thing is only 4 bytes. So what's happening? This has the same memory address as y. So x and y are literally the same spot in RAM. So when you have a union, you can treat the member variable as an integer or as a float, and it's literally the same spot in RAM. So when you write 42 to y, you're overwriting x. And that's why we got that a random cat. Okay. And that's why x changes, right? If we set y to be 0, then you'll see that x is 0 as well. When you write to 1, you write to the other, because they are the same spot in RAM. It is a way, there's a couple different uses why you'd use a union. Big one is just to save on RAM. Like if you have a variable that in the upper half of the function needs to be an integer, and then maybe later on you don't need the integer anymore, but you need a float. Normally these days we would just be like, okay, well, RAM times cheap, anti floatf, you know. But if you want to save on RAM, you can have that integer and the float exist at this same spot in memory, and you can just treat it differently. You can treat it as an integer or as a float based on your needs. And so if you are really trying to compress the amount of memory you need, floats are unions are a way of doing it. Also, sometimes you'll read in a bit pattern from a network and you don't know what type it is. And so you like read it into a union, and then you can later on, like when you find out like, oh, they sent me a float, then you can pull out the .y on it, right? So, you know, you can have something like, you know, if, you know, turned out to be a int is true, then we, you know, print it out as if it was an int, otherwise print it out as if, you know what I mean? So like you can sometimes read in a bit pattern and have no idea what the type's supposed to be. And then you just read it into a union and then treat it as an int or a float, depending on later on. You're like, oh, that was an int. Okay. So kind of a niche thing. I can't remember the last time I've used a union professionally, you know. I know I have at some point in the last 20 years. I know at some point I've used one. Maybe to like reinterpret bits or something. But none are actually coming to mind. Like this is really a C artifact. Variants are a type-safe version of that. So if you save an integer into it, it knows it's an integer. And if you try getting a double out of it, then it'll be like, no, you put an integer in, you're getting an integer out. So it's actually less useful if you're trying to use it to like bitcast between two different things, doing a little level bit hacking like that. But variants are basically allow you to save on RAM. So you can have a variable that can have different types, and you can find out what type it is. And you can say like if Raymond has value has something like that. I don't know. Like you can ask it like you can ask it like if it has an int in it, things like that. Okay, variant any. That's hilarious. Okay. So that's yeah. So variants are basically unions, and you know, if you want to have a function that returns sometimes a string, sometimes you know an int or something like that. So you can see up here, we've got a function that sometimes returns an integer, sometimes returns a string, sometimes returns a double. And so you can just return a variant, and then sometimes you get an integer out, sometimes you get a string out, sometimes you get a double out, and then you can you know get the different values out of it. Okay. You're back. Your dog is freaking out. Okay. You're in a union right now. It sucks. I'm in a union too. Not this kind of union. And Voss was like in set theory union. Unions are yeah, fairly obscure and a fairly niche thing. You've been in the union for 3.5 years, still waiting on the benefits you're promised at 3 months. That sucks. You know, see if you can talk to like your union ombudsman or union rep or whatever like that about it. My main gripe about the union is that they make me buy insurance that I can't use. And so if you tally up all the money between the district and myself on health insurance that I've never used in almost 10 years now, it's probably $100,000. I don't know. You know, it would have been nice if they even cut me a check for half that. That'd have been cool. You know, I could use $50K. Why not? So, well, what are we looking at? We are looking at C++ right now, my friend. And this is not normal C++. This is this is obscure corners of C++ day. Okay. And then the last thing I wanted to go over today for this little video on obscure corners of C++, we're going to do the optional. And the optional I actually use. Any invariant, I generally, I don't really see the need for them ever. I usually have a pretty good idea of what type I want. Yeah. But optional I like. Okay. So, well, also if you take 50B McKinney, I tailor 50B to the people in it. And so right now we've got Voss, who's a genius. We got Eggert, who's a genius. We got Raymond, who's like defeating Seaside 26 people third semester and first semester. And then Bruce and Caesar are very solid programmers as well, even though they claim to not be. So I tailor it to the students. Okay, so you should show read 2 for optional. Yeah, that's true. Vim / public / read 2. Okay, so this is a function that reads from usually the standard input by default, but it could be from any iStream. And if an error occurs, then it returns nothing. Okay, it returns null opt. And so this is actually a non-ironic, like actual use of a optional. So optionals can either have the value promised or nothing. So basically, let's say that you're making a function, and the function is gonna like return a file. Okay, like we'll call it like open map or something like that. So let's say we're gonna return an IF string. Okay, call this like open file, taking a string. And we're just going to go like IF stream. IF stream. There we go. Okay. And then we're going to return it. So we'll do ends.open s if not ends. Error opening file s. Okay, and then we're going to return it. Now, this is all well and good. You know, it's fine. You know, auto ends equals open file. Yes, salaries.csv. Cool. Trouble is, you know, sometimes you need to return an object, and if you can't open the file, it's like, what do you return, right? In the case of an IF stream, you know, you can return an invalid thing, but the thing is, like, this guy's gonna have to, you know. So sometimes, like, you call like search, and it's supposed to return an integer, but you know it's not found, or you know, like sometimes like you just try doing something, like you have a stack. You say, hey, give me the top of the stack. You know, you have a stack of integers. So that should normally return an integer. But what if the stack is empty? What integer do you return? You know? Does that make sense to you guys? Like, if you ask for the first element in a data structure and the data structure is empty, do you just return 0? Like, do you throw an exception? That's typically what people do. You know? Return -999, you know, and then one day somebody puts -999 into your data structure and your code's like, it's not found, it's empty, you know? And so that's why optionals are nice. So like you can do this instead. You can say return an optional IF string. Yes. And then you can say if ends, and that means if, you know, value is found, then, you know, parse the file. Otherwise, you know, die or handle it or something, right? Or if we were handling like, yeah, let's just do that stack option. So like, let's say we're stack pop. So let's say we've got some stack class, and we're going to just get the top value off of it. If stack dot So if st.size int retval equals st.top, st.pop, return retval. So if there's a value on the stack, we get the top value of the stack, we delete it and throw it away. The fact that pop doesn't actually return a value is kind of irritating to me. And then if there isn't anything, then we return what's called null opt. Okay? And null opt means there is no integer to return. And to me, this is a more sophisticated way than throwing an exception. Although, throwing an exception does kind of have the same effect, right? Like, there's no, like, you can handle it, right? Like, you throw something like, hey, you tried deleting from an empty stack, or you tried, getting the value and deleting from an empty stack. Go handle it. The flow is going to look a little bit different. But to me, an optional actually makes sense, because every time you get from it, like, there's a possibility it's empty. And is it slower? Probably. And do you guys know how the stack class actually handles it? Like, if you just have like stack, like we just say stack dot pop. Like, do you know how it just like handles it, like by default? You don't know? Like, because think about it. Like, I'm trying to get a value that there's nothing on the stack. This is an empty data set, right? Segfault. The standard library by default will just explode. Like, oh, that's on you. So I personally, it's like, I get it. Like, they're writing a standard library. They want it to be fast. Presumably, people are going to be checking to make sure the stack isn't empty prior to popping it. And so it'd be a redundant check for them to do it. Personally, though, I do not write code that will explode under normal circumstances. So I would do something like this instead. So instead of that, I would say, instead of an integer, we're going to return a optional. Yeah. And what the optional means is, like, sometimes we're going to get an integer back, sometimes we're not. And so we just say this, if x, then we got an integer. All right, cool. So cout x dot value, and otherwise error tried popping off an empty stack. You guys understand? Why did you do this? Okay. Like, as much as I like code completion, like, I find like it inserts as many bugs as it saves, all the extra curly braces and things it puts in. So what do you guys think of this approach? You can also say if x dot has value. You're gonna put the parentheses in. You're gonna put the no. Okay, no. Yep, there we go. All right, no. So annoying. All right, this is the same thing. So if it successfully holds a value, print it out. Otherwise, error. It's like try catch, except not, right? Like, there's no exception being thrown here. A lot of people hate exceptions, by the way, and will actually like compile their code with exceptions disabled, because they're not a zero cost overhead. The system does have to put in like exception handlers and things like that to like catch your code. It actually will slow your code down slightly if you have exceptions turned on. And so this would be a more explicit way of handling it. Now, some people like exceptions because it makes the flow control isolated, right? Like the error handling could all be put at the bottom, right? Like, you can just do, with the exceptions, you can just say try, and then you just like do all these like int auto x equals stack top. Right. So with exceptions, you can put your error handling all in one place at the bottom. Right. So now I don't have to have an if statement on all of these things. Right. Whereas when I'm using the optional approach, then every time I get something, I have to check to see if it was valid. And with an exception, then you can clean up your standard, like this is your normal code flow. And then if any of those things fail, then it just jumps down to the catch block and prints an error message. So there's pros and cons to be said about both of them. I'm fairly agnostic on it. I probably would use exceptions here, just because having like a big if statement with a repeated error message every time, if I'm doing all these pops. But I'd probably also just use a for loop. I don't know. I can go either way on it. I don't really have strong opinions. But yeah, you can either use try catch with a standard approach where you throw if you pop off an empty thing, or you use an optional and just say nothing was returned. And to a certain extent, like this is actually maybe a little bit cleaner, because if a function can possibly fail to return a value, then you can represent that now using an optional. And optionals are new. Like they're not as old as exceptions and the other things. Or you could just do what the standard library does and just die. Yeah. But not dying nicely. You can just segfault. Like if you try, that's the error's fault. It's not mine. Yeah, so you hate code completion. Yeah. Okay. So writing code in C++, it's 100% safe. It's not. Honestly, it's not. It's not that it's hard. It's the reason why the standard library doesn't have it in there is because because they want to have optimal code, right? And you're probably going to be doing something like this. You're probably going to be having code that says while stack.size, while there's still things left on your stack, then auto x, like int x equals top. Right. This is how like standard library code is supposed to work, right? The user is going to check to see, is there data remaining? If there is, grab it, print it, delete it. So since the user is already checking to see if there's things there, it would be redundant for the standard library code to check to see if there's data there as well. It's sort of like, don't repeat yourself, right? Like, but like I don't like writing code that'll explode. I really don't. I don't like it when something segfaults without any warning, right? Like you saw that it just says segmentation violation. I don't like that. In my code, I will gladly accept a 1% slowdown in my performance for my code to not just explode like that. And I might change my mind if I'm doing like high frequency trading, for the stock market, or if I'm in a game and I'm in a really hot loop. Sure. Like I get why the standard library people do it that way. It's just not my own personal philosophy for coding. So that is some obscure features of C++ for IS50B. Next up, we're going to switch videos and talk about Rail a little bit. But in summary, optionals I use any invariant. I mean, if I need them, they're there. But that's the one that I've used non-ironically the most. All right, save it and see you guys in the next video.